Alrighty, going to do some projectile motion problems, starting with number 21. We have a dart thrown horizontally with an initial, so it's horizontal, we talked about that situation in the notes, with an initial speed of 10 meters per second. And I'm just going to note here that's at 0 degrees. The bullseye at a dartboard, it hits at a point Q on the rim, vertically below P, 19/100ths of a second later. So it's thrown like this, and bends down, hits, there's the bullseye that they're aiming at, hits here, and there's my delta Y. What is the distance P to Q? So they want to know what is the distance from the point where it was thrown to this point here. So do we know how far away we are from the board? No, that's one of the things we need to find. All right, so I guess that's pretty easy. So let's just set up our horizontal and vertical and see what we know, and then we'll take it from there. So there's my vertical variables. Here I've got those. These are the same time, and I do know that. All right. What else do I know? Of course I know this. And I do know the initial vertical velocity, since it's a horizontal launch. This is 0. So I do have 3 things here, which means I can find a fourth. Now I already have the time here, so let's see what we can do. Oh, and I know that, sorry, I do know this. There's my 10 meters per second. All right, so this is set up so I can do these 2 parts independently, I think. What are they asking for first? In other words, I don't have to find one thing and then bring it over to the other side, like the example that I showed you. So this is unusual to have this much information. This is a little bit over determined because we know that time. What is the distance PQ? So I think to find that, I need to know this distance, and then I need to know this distance. So I think I actually need to do B first. How far away from the dartboard is the dart release? So I think I'm going to find my delta X first. That's part B. So delta X is equal to Vx times the time. That's 1.9 meters. And then to do part A, I can find that delta Y, and then that's 0, right? So, oh, that's 0.19, not 1.9, sorry. Got distracted by that answer. So, negative 4.9 times 0.19 squared is negative 0.177 meters. So if we want to know the distance, or the from P to Q, that's a little right triangle with 0.177 here and 1.9 here. Now this is one of those very long, skinny right triangles. It's really would be very hard to tell if you had like a physical construction of this, the difference between this and an isosceles triangle. It's such a small difference here. And so this is going to be very, very close to 1.9, but we can Pythagorize those anyway, just to see. Yep. So 1.91. There's an extra centimeter there. All right. I was going to check that against the book answers, make sure that we're good. 18. Oh, I answered the. Oh, that's the. Oh, I guess maybe I just misinterpreted. It looks like they're reporting this as the answer for A. What is the distance P to Q? Oh, I guess toward. Oh, sorry. I took that to be point P. Point P is here. So all that Pythagorizing was unnecessary. That's the answer for A. So I could have done that first. All right. Sorry for any confusion there. 23. Projectile is fired horizontally, so I got another horizontal launch from a gun that is 45 meters above flat ground. Emerging from the gun with a speed of 250 meters per second. How long does the projectile remain in the air? At what horizontal distance from the firing point does it strike the ground? And what is the magnitude of the vertical component of its velocity as it strikes the ground? Okay, so let's set up our two columns. And see what we know. Okay, now this I don't have to break up into sine and cosine because it's all horizontal. It's all horizontal and no vertical. Right, those are the, you could think of those as the components of this, right? It's got a I component of 250 and a J component of nada. All right, the 45, that's going to be negative because it's going down. That's a super, super easy common mistake to make, leaving that negative sign out. Now I can find the time here. I do believe that is the answer to part A. It is. So let's see, I got delta y equals 1/2 at squared plus vit. That's going to be negative 45 equals negative 4.9 t squared, and then the VIT part's gone, so I don't need any fancy calculator work to do that. I just need to know what is the square root of 45 divided by 4.9. All right, that's my answer for A. Part B. At what horizontal distance from the firing point does it strike the ground? So they're looking for, that's delta x. So oops. So about 750 or so. I'll call it 758. And last part. What is the magnitude of the vertical component of its velocity? So that would be, that's this, right? And now I know what this is here. So I could use that, but I do actually have everything that I need, and I have an equation that will relate those, so I don't necessarily need to bring that time over. But now that you have 4 out of the 5 things, it's your choice as to which equation you want to use. I'm going to use this one. VI squared, that's 0, plus 2a delta y. So VF is equal to the square root of 2a delta y. Which is about 29.7. Now that's the vertical. That would be speed. Did they say speed or velocity? They said velocity, so that means I need to include direction. And so this thing's going down. That vertical component is going to be negative. Remember, when you do this square root thing to find the VF, you have to decide based on the context of the problem which direction. So you could say either negative 29.7 meters per second, or you could say 29.7 meters per second down. Let's see, just check those answers. Oh yeah, it looks good. I even have the same significant figures as I do. Woohoo! Number 25. All right, current world record motorcycle jump is 77 meters. Set by some completely insane person. Assume that he left the takeoff ramp at an angle of 12 degrees. And that the takeoff and landing heights are the same. Neglecting air resistance to determine his takeoff speed. Okay, so I don't know this. I'm just going to call that V, right? So this here, the Vx would be V times the cosine of 12, and this Vy would be V times the sine of 12. So I'm going to set up my two columns, because that's what you do when you're doing projectile motion problems. And the time, and then here all right. VI, I don't know what it is, but I know that this is an expression for it here, that it's going to be V sine 12, and I know that this is V cosine 12 while I'm at it. Don't know the VF, although since he's taking off and landing from the same height, it is true only if he's taking off and landing from the same height. If that delta y is 0, it is true that this would be the negative of that because of the symmetry of these parabolas, and this is constant acceleration. You need to think about that. If you need convincing of that, I probably could convince you pretty easily. So I actually have 4 of those things. That might make things a little easier, perhaps. And delta x, I know, is 77 meters. Now that might look like we have a whole lot of stuff, but the problem is I don't know what v is. So I actually have 2 variables. I don't know what t is, and I don't know what v is. So that smells like a system of equations, doesn't it? So let's see what we can do. Let's see if we can write an equation. We might be able to, let's see, if we do the equation that relates these things, we might be able to find v and then finish that way. Could we find v, or are we just going to, let's see what happens. So the equation that relates to those things is a delta y. No, that's just going to be a 0. You can set it up if you want. That's not going to give us anything useful. You could try if you want. So what I'm hoping to do is set up 2 equations that have a v and a t in them. So I'm going to ignore this and write the equation that relates those. That's the same. This one. All right, so delta y is 0 is equal to negative 4.9 t squared plus v sine 12 t. And remember, sine of 12 is just a number, right? And then, what's the equation that relates these things? It's delta x. Sorry, I should write it down first. Is that a good example? Is equal to Vx times t. All right. Now what? Well, we need to do some kind of one of the techniques that you know for solving a system of equations. And I don't know, probably I think substitution is the way to go here. These are not linear equations, so the matrix methods and Gaussian elimination, that sort of thing. That's not going to work. That's for linear equations. But substitution always works. So that's true, right? So let's go ahead and sub that in over here, being very careful. Cosine squared of 12 degrees times v squared plus, and then when I substitute this in here, 77 over v cosine 12, the v's are going to cancel out because this is going to be on the bottom, and I have sine over cosine, which is tangent of 12 times t. Oh, and I forgot I lost my 77. There's a 77 in there. All right. Now, what do you do? Oops. And there's no more t's because I substituted this in place of that. So the v's cancel out. Sine over cosine is tangent. So that's just a number, right? So let's see what we can do with this. Let's get the calculator out and see if we can wrangle this into an answer. So here I've got a whole bunch of stuff, but the only thing that's a variable is that. So I'm going to leave that on the bottom right there, and then I'm going to evaluate the rest of it. So I have negative 4.9 times 77 squared divided by the cosine of 12. That closes that, and then that closes the cosine expression, and then you just square that. All right, so that's negative 30,000. I'll keep that many sig figs for now. I won't report that many in my answer. Plus, and then this is a number, 77 tangent 12 is 16.369. Okay, algebra. I'm going to move this to the other side and then cross multiply. So my final answer, you can write out that step if you want, is going to be this divided by that. Now that's 30,365 divided by that thing, and that is not the right answer. Wonder what we did wrong. Wonder what I did wrong. Let's see. Let's go back and check out our equations here. That's good. I'm not seeing it yet. Just check. Is that squared? Oh, did I take the square root of the... Oh, maybe I did it right. Oh, I just didn't take the square root of that. I think I'm probably fine. Are you yelling at the screen again? Oh, yeah. There we go. Sorry, just didn't finish. So V is equal to 43 meters per second. So that's a little tricky, a little calculator work, a little algebra, some substitution. I think I told you before, this book really likes problems that end up as systems of equations for whatever reason. So get used to it. All right, sorry about the confusion there. Just forgot to take the square root. All right, last one of this set, number 27. A certain airplane has a speed of 290 kilometers per hour. I'm thinking we might want to make that into meters per second. We'll see. And is diving at an angle of 30 degrees below the horizontal when the pilot releases a radar decoy. Now, if you release something, that means that at the instant that it's released, it's going to have exactly the same velocity as the airplane because it was attached to the airplane, right, or on the airplane. The horizontal distance between the release point and the point where the decoy strikes the ground is, now of course this is if this is the velocity, that's not the path, that's just the instantaneous velocity. As soon as it's released, gravity is going to start bending it downward like that. This is 700 meters. That'd be my delta x, right? How long is the decoy in the air, and how high was the release point? All right. So I'm going to go ahead and change that over to meters per second. To get to meters, going to have to divide by, multiply by 1,000, and then to get to hours, I'm going to need to, well, let's set it up. Let's do our little, just to make sure. So a kilometer, a kilo means 1,000, and 1 hour is the same as 3,600 seconds. So I need to multiply by 1,000, divide by 3,600. Oops. That's 80.6. All right, let's break that velocity up into its components. So this would be, this is 80.6. This is 30 degrees. The sine of 30 is negative a half. Well, sine of 30 this way. So this is going to be, since it's going down, that is going to be negative. Much importance there. 40.3 meters per second. And then here, 80.6 times the cosine of 30 is 69.8. All right, so now I can set up my vertical, horizontal stuff. All right, so what do we know? We know acceleration, initial velocity, final velocity I don't know, delta y I don't know, time I don't know. Vx, the velocity in the x direction, is a constant velocity, right? That's not going to change. And then the delta x is 700 meters. Okay, so setting up the equation, delta x is equal to Vx times t. Oops, Vx is the thing that I know. Looks like it's about 10 seconds. Yep. And that's portable to here. And then, what is the other thing? The height of the plane? Is that, am I answering the questions? Yeah, how long is it in the air, and how high was the release point? That's delta y, or the positive version of delta y, because delta y is going to be negative. and they're saying how high. You cannot give a negative answer to the question, how high is something? So we'll have to report the absolute value of it. That's part A. So here, for part B, delta y equals 1/2 at squared plus vit. Oh, I know the time. All right, so let's see, negative 4.9 times 100 minus 403. So that is 893 meters. And let's just make sure that that is correct with the book. It sure is. Even got the sig figs right. No, I didn't. Just kidding. They have 897 here, so that's just some difference rounding somewhere along the way. But that's good. Solid. See you later.